Let me introduce you to a new type of equation called a quadratic. This type of equation, or pattern, is unlike linears, which have a constant rate of change between coordinate pairs, and exponentials, which have a constant multiplying rate that causes coordinate pairs to increase or decrease rapidly. Now with quadratics, there is no constant rate of change or a constant multiplying rate. Instead, what is constant is the rate at which the rate increases or decreases. Now the equation of a quadratic in standard form looks like y equals a times x squared plus bx plus c, and can also be called a polynomial of the second degree. This is because polynomials is a fancy term for any and all equations that contain variables raised to different powers, like y equals x to the 4th power plus 2x plus 1, or y equals x to the 8th power minus 6, or even y equals x to the 5th power plus 3x squared plus x. The polynomials are then categorized by the degree of the largest exponent. So the equation y equals x to the 4th power plus 2x plus 1 has a degree of 4, since the largest exponent in the equation is 4. That means y equals x to the 8th power minus 6 has a degree 8, while y equals x to the 5th power plus 3x squared plus x has a degree of 5. Hopefully this explains why all quadratics can also be called polynomials of the second degree, because the highest exponent within a quadratic equation is always going to be 2. Be careful not to confuse the equations of exponentials with the equations of quadratics and polynomials. In equations of exponentials, the variable x is the exponent, whereas in quadratics and polynomials, the exponent is a specific number. This can easily be confused, so be careful. Do you want to learn more about quadratics? Check out my next video on how to evaluate quadratic equations. See you then!